Hi, this is a little lesson on basic probability. We're going to be taking a look at page 472, numbers 14, 16, and 20 out of the textbook. Okay, page 472, number 14. Find the probability of the event. Okay, choose a 10 from a deck of 10. Choose a 10 from a deck of cards. So here's the basic formula for probability. It's the probability of the event equals the number of events over the number of in the sample number. So let's just kind of identify these pieces here, and we've got the probability of a 10. Right? We need to find the probability of a 10 and the number of events over the sample number, the number of the sample. And we just got to keep on filling these in. Well, we have 10 over the sample number. And, well, how many cards are in a deck? Well, we know there are 52 cards in a deck. So the whole sample that you could choose from is 52, right? Well, how many 10s are there? Well, there's the 10 of hearts, right? There's a 10 of clubs. How's that shape? Boom. There's a 10 of spades. Oh, that's not a spades, but something like that. And then a 10 of diamonds. So there are 4 different 10s that you could possibly get. So then it'll be 4 over 52, and you reduce that down to 1 over 13, and that is approximately 0.08, or about 8%. So there's an 8% chance of choosing a 10 from a deck of cards. Let's take a look at number 16. The directions are still the same. Find the probability of the event. Roll an even number with a die. So this probability of an even number. Even number. My handwriting is horrible, I know that. And over the total sample, and if we just fill this in, it's the probability or the event is an even number over the number of items in the sample. And the probability of an even number, well, if it's a die, you've got a 1, a 2, a 3, we've got a 4, we've got a 5, and then a die with 6. So there are 3 opportunities, or 3 events that could be even, and the total sample is 6. And reduce that down to 1/2, and of course 1/2 is 50%. Let's take a look at number 20. Find the probability, again the directions are the same, guess a random person's birthday correctly and exclude leap year. So it's going to be the probability of guessing a birthday. And that's going to be equal to, well, to the guess a birthday over the sample, the total number of items in the sample. And so here's the clue. It's guess a birthday. You're guessing one birthday, right? So the total possible events is going to be 1. And then the total possible numbers in the sample, well, how many days are in a year, right? I guess a person's birthday. It's how many you only have 365, right, different possible birthdays. And that's because you're not counting leap year. 365. So it's going to be 1 and 365. And that's equal to 0.0 when you do the division. 27, and that's approximately 0.27%. Okay, hope you found this helpful.